Hi everyone. So welcome to Design and Analysis web series. I have posted so many concepts related to design and analysis algorithm like recursive and non-recursive algorithm, greedy algorithm, dynamic and so on. So if you want to know more about this, kindly subscribe and follow.
Hi everyone, welcome back to DAW series. Today we are going to see the next example, quick shot. There are so many shots are available. Heap shot, radix shot, bubble shot and so many shot. Last previous class we have seen the what kind of topic shot we have seen? Merge shot. Check that video. So now moving on to quick shot. Quick shot comes under the concept of divide and conquer. We shall check it out. This unshorted order comes under which case? Either best case or worst case. In best case, we divide the set of element into two, whereas in worst case, we cannot divide the set of element into two. For example, we can take the list of elements. The given list of elements are 25, 100, 10, 85, 40, 60. In the given list, the total number of n is equal to 6. So we shall see the step-by-step process for the quick shot. So what are the various steps involved? Number one, pivot or the partitioned element should be calculated or identified in the given set of element. So which is the pivot element in the given list? So either we can take any one of the element as the pivot or partitioned element. For example, 4 and 5 are any element, either not 4 or 5, 3, 1, 0, any element can be taken as a pivot or partitioned element. So what we can do now for easy accessing, usually the user will be taking the first element as the pivot element or partitioned element. So the first element is identified as a pivot or partition element for easy accessing. So we shall move on to the next step, I, J. So what is I? I is nothing but left scan. J is nothing but the right scan. So J is the right scan. So I is the left scan and J is the right scan. So one full scan we have to do for each cycle. One left scan and right scan. Fully we need to process. Then we have to check the proper condition. What are all the two conditions? We have to check it out for the left scan and the right scan. This is the second step involved in the quick shot. So once if it is fixed, we will be fixing the partitioned element. Then it is divided into two set. One set on the left hand side which is less than the partitioned element and the right hand side greater than the partitioned element. So after that again recursively we need to do the same process again and again. Okay. So shall we repeat this step and we will be doing the left scanning and the right scanning one by one with the given list of element. So first we will take the pivot element 0th position as a 25. So P, what is the condition for left scanning? Consider the pivot and the first position element. We need to compare these two elements. Likewise, right scanning, we need to compare the fifth position, last position and the pivot element. So these two should be compared. For the left scanning, pivot element should be greater than the first position. Conversely, pivot element should be less than the given position of the element. So these two conditions should be satisfied to proceed the one full cycle scanning. So after the completion of the scanning, we need to check the condition. So what are all the condition? So we will check what are all the various condition. Only two condition, not more than that. I less than j. If I less than j, we need to swap. The another condition is I greater than or equal to j. If it is less than, swap I comma j. That's it. And we have to continue the process. If it is greater than or equal to p and j should be swapped and we need to fix the position of partition element. And further again it is divided in recursively into two set and we need to do the process from the beginning. So these two conditions we need to check it out after completion of one cycle, one full cycle of left scanning and the right scanning. What is the pivot element? 25. What is the first position? 100. So 25 greater than 100? No, false. So stop the left scanning. Now we have to do the right scanning. So This is not, if scanning is not to be processed, therefore we need to go for the right scanning. What is the fifth position? 60. Greater than, what is the pivot element? 25. 60 is greater than 25. Yes, it's true. Then we need to do the right scanning of the next position. Which is the next position? Decrement. We need to decrement the value of the j. So previously it is 5. So now we need to decrement the value of j as 4. 4 means the fourth position. What is available in the fourth position? Fourth position is nothing but it is the 40. We need to compare the 40 with the 25. 40 is greater than 25. Yes, the condition is true. Therefore, we can proceed with the scanning the next element. 85 is compared with the 25. Yes, it is greater than. We can further proceed with the next scanning of element 10. 10 is compared with the 25. So 10 should be compared with the 25. No, here the condition fails. We have to stop the right scanning. So one full left scanning and the right scanning is completed. Now we need to check the condition. So the current value of I is 1, current value of j is 2. So 1, and then j value is, I value is 1, j value is, what is the j value? J value 2. This is I value 1. 1 is the I value. J value, what is the j value? 2. So 1 less than 2. Which condition it falls? First condition. What is the first condition? I less than j. What we need to do? We need to swap I and j. I and j means ith position value and jth position value should be swapped, and we need to continue the process. What is the ith position? First position. First position is 100. So ith value is first position and that is 100. What is the jth position? Second position. So second position is 10. We need to swap these two value and we need to continue the process of left scanning and right scanning. Continue. Continue. Okay, so now we shall swap 25, 10, 100, 85, 40. Remaining will be the same. So 40, 60. So the remaining all same. Only 10 and 100 should be swapped with each other. So now again we will continue the process. So what we will continue? We need to do the left scanning and the right scanning. So we shall take the I value and j value. So what is the I value? First position. So what is the j value? Second position. So we need to do the comparisons with the first position of pivot element. Yes, 25 is greater than the 10. 25 is less than the 100. So stop scanning. So we have completed one left scanning and now we need to do the right scanning. So right scanning we need to compare 25 with the 60. Yes, correct. Then we need to do the next element comparison. So 25 is compared with the 40. Yes, 40 is greater than the 25. So we can do the next element, third position element. 25 is compared with the 85. Yes, true. Then we can process with the next position element, second position. 25 is compared with the 100. Yes, true. 100 is greater than 25. Yes, do the process. First position. 25 is compared with the 10. No. So 25 is greater than 10. No, no. We have to stop the right scanning. So one full complete left scanning and right scanning is completed. So here completed the right scanning, 25 less than 100. There we have completed the left scanning. So one left scanning and one right scanning, one cycle is completed. Our I value is 2, current value, j value is 1. So 2 greater than 1, I greater than j. So it satisfies the second condition. So what we need to do? We need to swap the partition element and the jth position element. So who is the partition element? First position. 25 is the partition element. So 25 is the partition element. Jth position is 1. 1. What is the position available in the first position? So that is 10. So we need to swap the 10 and 25 and we need to fix the position. Fix the position means that is the final position of that particular partition element. 25 position is, this is the position. We are fixing it and we are dividing the set into 2. Set 1, 10, the value of 10 is in the set 1 and the remaining element is in the set 2. So it is divided into 2 set. So set 1, this is, and this is set 2. So what we need to do? Again, we need to start from the beginning. So the set which is divided on the set 2, we can start it from the beginning such that each position can be determined from the 0, 1, 2, 3. So now the 0th position for easy accessing, consider that as a pivot element. What is the I value, J value? 1, J value is 3. Now compare the 100 with 85. So we will do this, start doing the left scanning. So 100 is compared with the 85. Yes, it is greater. Similarly, we need to scan the next element. 100 is compared with the 40. Yes, we need to do the next scanning. 100 should be compared with the 60. So 100, yes, true. So completed the element. Now we need to do the right scanning. One left scanning completed. So now we need to do the right scanning. So for right scanning, we need to start it from the third position. So 100 should be compared with the 60. So 60, no. 60 is less than the 100. So stop the right scanning. So one right scanning, one left scanning completed. We need to check the condition. What is the condition? Current I value is 3. Current J value is 3. So greater than or equal to, then what we need to do? We need to see the second condition. It satisfies the second condition. So I is 3 and J is also 3. So it satisfies the second condition. I greater than or equal to J. So I equal to J. That is 3 equal to 3. So it satisfies the second condition. We need to swap the pivot element and the jth position element and fix the position. So pivot is 100. Jth position is 3. 160. So 160 should be swapped with each other. So 100, 60, 85, 40, 100. Fix the position of 100. So that is the exact position of 100. We are fixing it. Now this is divided into one set. So again we need to start it from the beginning 0, 1, 2. So 0 is defined as the pivot element 60 and I value, J value. I is defined as 1, J is defined as 2. Left scanning, right scanning. 60 should be compared with 85. No, stop scanning. No, stop scanning. And 60 should be compared with the 40. Right scanning. No, that is also false. So stop scanning. Now compare the I and J. Current I value is 1. Current J value is 2. So I is less than J. First condition. So if I is less than J, we need to swap the first position and the second position element. So what is the first position element? 85. Second position element is 40. So we need to swap 85 and 40 and we need to continue the process. So 60, 40, 85, 100. So again we need to check the condition. 100, 40. So 1 and 2. Pivot is P. Again IJ. Compare the first. Yes, it is greater. 60 should be compared with 85. No. Stop scanning. Do the right scanning. 60 is compared with 85. Yes, true. We can continue the next scanning. 60 is compared with 40. No. Stop the right scanning. Now compare the I and J. So 2, current value of I is 2, current value of J is 1. So I is greater than J. Second condition. It satisfies the second condition. So we need to swap the partition element and the first position element. So first position element is 40, pivot element is 60. So 60 and 40 should be swapped with each other. So what is the first position? 40. So first position of the element is first position of the element is 40, 60, 85. We have swapped. So now it is fixed and the set is divided into two set 40 and 85. Two set is divided. So definitely the left side will be the less than element. So if you take the same element, individual element, na, everything will be the same. Pivot is 0, left scanning 0, right scanning 0. So everything will be the same element, one individual set also. If you check the condition also, the same position will be fixed there. So what we have done, we have shortlisted the unshorted list. 10, 25, 40, 60, 85, 100. So using the quick sort, this is one of the case. Unsorted list. So the list is not in any kind of ascending or descending order. So this is the best case. So we are dividing the set into unsorted order. So 35 minus 1, 1, 3. Na? For example, this is an unsorted order. This is not in any sorted. If you are considering sorted order, na 10, so 300. So this is in ascending order. This is another case. If you consider this case, na another case. Descending order case also you can consider. Descending order means the starting number 500, then 400, 300. So these numbers are arranged in descending order. So either it may be unsorted order case or it may be sorted order. Unsorted means best case. The set will be definitely divided into two set. Suppose if you are considering the sorted order. So this is an unsorted order. What I am telling you now, definitely the set will be divided into two set. So the time complexity for dividing the set into 2 is 2t n by 2 plus 1. So n log n. That is the best case. The go of n log n. Best case time complexity for quick sort in an unsorted order. Whereas if you consider the worst case, maybe ascending or descending. We shall take another example arranged in ascending order. We shall take the same process for the quick sort. So P is the pivot element, 0th position. So I, J, first element, fourth element. Now compare the 10 with the 20. Left scanning. No. This is an ascending order. Okay. So what we need to do? Left scanning. We need to do the first left scanning. 10 is compared with 20. No. False. So we shall do the right scanning. So 10 should be compared with the 50. Yes, we can proceed. So scan the next element. 10 is compared with the 40. Yes. Proceed with the next element. 10 is compared with the 30. Yes. Proceed with the next element. 10 is compared with the 20. Yes. Proceed with the next element. If you decrement now, it will become the pivot element. So it will stop the scanning. Now completed one left scanning and the right scanning. Compare the I current value, J current value. 1 is greater than 0. Second condition. We need to swap the partition element and the jth position. What is partition element? 10. What is the jth position? 0. Same element. So partition element is also 10. 0th position is also 10. If you swap the same element, it will be residing in the same place. So fix it. And again, it will be divided into one set only. It is not divided into two set. 20, 30, 40, 50. Again, further what will happen, the same procedure if you are following na, it will scan the again and again the n times of n element will be scanned again. So again if you do the same process with this set of element, 20 will be fixed, the remaining 30, 40, 50. Likewise if you scan the next na 30, 40, 50. So likewise these set of elements will be further divided into big O of n square. So worst case time complexity for sorted order, either it is ascending or descending. So either it is ascending or descending. Worst case shorted, ascending or descending. Okay, both the cases time complexity is big O of n square. So best case time complexity is n log n. Worst case time complexity for the quick sort is n square. This is the time complexity we are calculating for the quick sort. Descending order, if you take now the same process. So this is a descending order. If you take descending order now the same process, the set will not divided into two. Okay, so again what will happen? This is pivot. We shall take ij 1 and 4th. 500 is compared with 400. So what we can do? Either we can proceed. Yes. Again 500 is compared with 3. Yes, you can proceed. 500 is compared with 200. Yes, you can proceed. 500 is compared with 100. Yes, proceed. Last element, stop scanning. Do the right scanning. 500 is compared with 100. No, stop scanning and compare the ij. Okay, so greater than or equal to second condition. So pivot element and the jth position should be swapped and fix the element. So 100 and 500 will be swapped with each other, and we are fixing the position of 500 as the last position. So 100, what is the first position? 100, 400, 300, 200, 500. 500 fixed. The set is not divided into two set, only one set. So big O of n squared. Again and again we are trying to scan the n elements. Okay, so same pattern. Ascending order and descending order are the same pattern. They are not dividing into two set. Only best case is dividing unshorted. Here it is big O of n squared. So the time complexity for the best case and the worst case for the quick short is different. So big O n log n is for best case, big O of n square is for the worst case. Thank you.